Well, ladies and gentlemen, thank you for this opportunity to be here. Thank you for the excellent music, 100 years Finnish music. Special thanks for organizers to really have this opportunity to discuss today. I would like to also give a special thanks to Professor Kauko Leiviskä, who I met there just as an accident. That was really nice that you are also here. Thank you for the education 30 years ago that you guided for this paper and board industry, and it's really a pleasure to have you here today. Also, special thanks for CEE and Pekka Tervonen and his group. I have worked together with them regarding a lot of projects. Also this what I'm presenting today. I have got some support from their group. They are there at the stand T2026, and Pekka promised that everyone who is visiting there will get a free beer, 1 bottle of beer. So you are all welcome, and there are good reasons to visit there. My presentation really today is regarding this water-based barrier coatings, which means that packages, paper and board packages can be totally recyclable and compostable already today, and more in the future. I will start my presentation by explaining a little bit what is the structure of our company, what is background of our company, what we have done in the past, to somehow open up the picture that how much work there is behind this what we have achieved today. This way. I'm coming from this company CH-Polymers, which is producing styrene acrylate binders for paper industry, for board industry, for non-woven and paint industries. And then we have a company called Chemek. We are all under all these 3 companies which I have here, and later I will explain one more. We are under this kind of a slogan, in cooperation. This is like this in cooperation is like an umbrella for all these companies, and which means that we have a same private ownership background in all these companies. Chemek is really this kind of a specialty chemicals and industrial service company, specialized especially for slurry makedown, and they have technologies to make different kind of slurries, and they have some specialty chemicals for that purpose as well. Then we have a third company, which is FP Pigments. They have a unique solution to replace titanium dioxide, which is used huge amounts in paint industry, in plastic industry, and also in some specialty papers, like Bible paper example, which is very thin. There you need titanium dioxide. And they have a pigment which can replace cost-efficient way this titanium dioxide. It can't replace totally, but partly, from 50 to up to 80%. You can replace that by the solution. History of these companies is so that this Chemek was founded 1987. Then these following steps with FP Pigments. Then what comes to this CH-Polymers, we go to the year 2009. There was in the past there was a company called Raisio Chemicals, which was based here in Finland. And then Swiss company SIPA acquired Raisio Chemicals, and then came BASF, German chemical giant, who took over the Swiss company SIPA, and then came EU competition authorities, and they said that now BASF is too big in Scandinavia, and you have to do something for your facilities here. And then at that time, Kemek established CH-Polymers and got these facilities from Finland. So there is one factory in Kaipiainen, and then the research centers, etc., in Raisio, near Turku. And then 2 years ago, we acquired some slurry make-down plants from also this time from BASF. How we work, it's really so specialty chemicals from FP pigments, emulsion polymers from CH-Polymers, and then this make-down service and some additional chemicals from Kemek, a lot of application know-how, and then huge R&D center. Compared to our size, we really have excellent facilities from R&D point of view. This is how we offer Finnish paper industry and European paper industry already. We have done that already in the past with let's say so that with normal products. We come later to this barrier what we are talking today, but this is the setup for all kind of products which we are producing. We are a small, innovative company having private ownership, so we are quite flexible and reacting quite quickly and making tailor-made solutions for customers. We have strong own research, and we do a lot of cooperation with universities, with Oulu University, Åbo Academy, Eastern Finland University, Kuopio University. We have a lot of laboratories. We have totally nine factories, and plus then this, and we have a laboratory at all mills places. And then we have this research center in Raisio, and we have pilot plants. One in Kaipiainen, one in actually two in Raisio, and one at Valkeakoski. These are the things I think I have covered already. This unique pigment solution. This is driver for us in coming years. New emulsion polymers we are developing. Then we have this. This is now a huge potential for us, and there is a big interest globally for these new water-based barrier dispersions. Then this is the company which I partly mentioned earlier. This biomass fractioning company, and it's called CH Bioforce, and we have a patented method now to produce lignin, hemicellulose, cellulose out of wood. A lot of what Hannu was mentioning earlier in his presentation. And this method, I'm sorry, are you hearing me well? Because this is moving a little. Yeah, and this company is. This patented method is really so that we have now, based on that, we have built 2 pilot plants, and we are getting, without any acids, we are getting out very pure lignin and hemicellulose and then cellulose. And this is opening up a huge market, so big market for us that this our in cooperation umbrella is not capable to handle that. We have a exclusivity contract with one stock listed company at the moment, and they have this year time to investigate that further, and looks like that there will be some factory investments now in the near future. But this is, of course, we are not capable to build those how to say, mills for this. We don't have enough money for that, but we have then a lot of things where we are using some of the raw materials which are coming out of this, and one thing is to use this biocomponent in these water-based barrier coatings. I'll show you shortly what we have today. So we have, for pigment production, we have one factory in Germany, in Leuna, one in USA, city called Rome, it's in Georgia. Then we have this Kaipiainen plant, which I mentioned. Then we have in Rauma, specialty chemicals plant. We have in Kemi Harbor, we have a pigment slurry plant. In Oulu, we have also one slurry making plant. At Stora Enso mill area, there we are. All other factories and plants are in own buildings. There we have rented the building from Stora Enso. Then we have one in Kotka, which is now quite interesting place for many reasons, and then Rauma. Here we are on the map. We have sales office and a factory in US. Then we have this factory in Germany, sales offices, research center. We have some sales offices in Asia, but no production there. Then I go a little bit more deeply to this water-based barrier coating. There was a You can find from the market that there is a need and pressure now for environmentally friendly barriers. Like was when you introduced me, this discussion to replace plastic. This is really now everyday discussion, and one discussion is to replace polyethylene plastic. One is to replace vaccines and fluorochemicals from food packaging. One good example, and everybody knows this hamburger box, where you go to McDonald's or any other hamburger place. You have this. They put this hamburger into the box, and then inside the box you have a plastic there to be like a barrier that the grease or fat is not going through the board. One other example is, of course, this disposable cup, that inside here you have a plastic PE layer which is working as a barrier for hot coffee or alcohol or whatever you have here, so that it's not going through. And this is what we can now replace with our solution. With this, let's say we call it here next generation barrier coating. It's water-based dispersion. We have there everything what I have represented today. We have some little bit something from all these companies. So some specialty pigments, some specialty chemicals, lot of different biofractions, and lot of research and know-how behind, I can say. This was the study when we realized this that there is this kind of trend coming to this board packaging area. We investigated that is this something that we can step in with our companies, and these numbers are from the year 2013, published by Paira Institute. Here are how barriers were used in different end-use sectors. 46% was in food, then pet food, liquids and beverages, and non-food applications. So this food was something we decided to investigate more. Geographically, it's divided so more or less so that one third in North America, one third in Asia, one third in Western and Eastern Europe, if you put those together. Now the recent figures have changed so that Asia has increased the importance for this also for this packaging industry, and that way also for barrier coatings. Then how much barriers were used, and it was at that the estimation was that 2020 it will be 3 million tons which will be used globally, and based on that is estimated that these water-based barrier coatings could cover 30% of that, which would mean 600,000 tons of that kind of a barrier, what we are able to do today. So we saw that it's a huge market. If we get a small part of that, it's really it will be great for us and for sure interesting to go in. We started the project. We put all this what we have done in the past for paper and board industry. That was somehow serving us extremely well for this to start to develop such a product. And I'm already repeating here many times, but we had these special pigments, binders and additives, then this know-how from mixing, from slurry making, and then this research facility, and then we started a project 2013. We went very early to Tekes. We introduced that what are our ideas and how we see this thing. Tekes was immediately supporting us. We have had now 2 Tekes-funded projects. Now we have one this Horizon 2020 project going on as well. But without this Tekes support, we would have not been able to do these products. Now we are in the state that we have so-called barrier product family for a couple of segments, and then of course there are a lot of different applications still where we are developing new products. But this is example. We have this kind of CHP bar 3200 is a marketing name. We make ready-made dispersion. Solid content is 50%. We deliver that to paper mill or board mill or converter. Converter is the one who is making, example, these cups. So meaning that it doesn't have to be paper mill or board mill to be able to use our barrier. They can buy this basic board wherever they want, and then if they have a flexo printing machine in the converting plant, they can apply this barrier layer on surface of that board. Existing applications where we are selling this product already today is really this hamburger wraps and boxes, so wrapping paper for French fries. When you get the French fries, they are very often in that kind of wrap paper, and there normally you are using these fluorochemicals there to make the barrier against hot grease or hot fat, and then in other fast food boxes, disposable plates, bakery products, disposable cups. A couple of customers are already using, Then we are going to the new fields there. So ice cream boxes, they are a little bit more demanding. It's an interesting, very interesting market. This packaging, because it's and then also this barrier, so that you have a example. If you put coffee here, it's a hot and liquid. Then you put French fries, which are also hot, and then it's fat, which is there, and then you put frozen something. You put frozen something which is then totally cold, and it needs to stay there weeks or months. So the time periods are totally different. It's French fries or hamburgers. It's a couple of, at least if I go with my children to McDonald's, it's only a couple of minutes, and everything has disappeared. So, but these are really something which can stay in a shop for a long time, and you have to have this working barrier there as well. We come to the replacement of aluminium here. Example. Today, aluminium is used for liquid packaging. It's used quite a lot. Also for this frozen food, pet food areas. There is a aluminium used today, but we are not ready on that field yet. We are not able to replace aluminium yet, but here where the polyethylene PE is used and where fluorocarbons are used, there we have already ready products. Another thing is this is another product. It's this. I don't know if you are how well you know these things, but or how familiar you are with these. But it's a big discussion. Is this Mosch and Moach barrier? Meaning this against mineral oil, so that when you have a recycled fiber and you are doing board from recycled fiber, and there is this ink which has been already, because the product has been printed once or twice, and then it is recycled, and then you put that against food, or you put that as a secondary packaging, so that you have something else covering the food, but then you have even the brown board box, and if you have used recycled fiber in that box, EU is now considering whether they are putting a law which is saying that how much mineral oil can go through that secondary packaging. And that is we have product for that. If that kind of a law is coming, it's of course helping our market. But anyhow, some of the producers are already wanting this kind of today. These are these are more. Then this kind of things are what we are developing at the moment. More future. It's this water vapor barrier. That's one of the most difficult ones. That how you control water vapor through board layer but. So far so good. So that we have started production. We are selling those products for these couple of applications, and now we are developing further with key customers. I have here some samples. It's this cup I already showed. This is made with PE, so I'm not saying that this one is made based on our solution. This box example is made to based on our product, so that it's on this side inside the box. This layer here is this our water-based barrier. then it has been glued at the converter. This is one of the things which is very, very challenging. Plastic is good. When you have a plastic here, this side gluability, how you then glue this side. This is it's easy to do when you have a plastic there, but when you have something else trying to replace plastic, it needs a lot of development to be able to glue this. We talk about hot gluability, and that happens with extremely high speed, because the production is dun 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 dun, and it needs to. There are automated lines which are putting it and then putting some glue, and a couple of seconds or less than second you have heat there, and it must be glued, which is then lasting maybe weeks at the shop, etc. So that kind of things we are developing and working with. We are not producing board, so it's up to every board or paper producer whether they want to say that whose product they are using here. I'm not allowed to say any of our customers that who is using in their cups, who is using in their boxes, but it's paper producers or board producers thing to market whether they want to say that there is a Finnish solution for that. For a little bit about the competition, we are number one, I would say. We are so far. This market is happening now. We are pushing this forward very, very hard at the moment. For sure, competition is there. Huge companies like BASF and other global companies are developing things, but I can say so that they, at the moment at least, they are behind us. Of course, they have a huge resources. They can put a lot of effort, and I'm sure they will pick up, and there will be heavy competition. But at the moment, they are behind. All our barriers are having these food packaging or food contact approvals. PFR for Europe is needed, FDA for US. All our products are recyclable and repulpable. They are compostable. There are a couple of things which are most probably coming. 2018, maybe some legislation things by EU. Then Tokyo Olympics 2020, they will be first summer Olympic Games, which are already now claimed to be that kind of that all cups and plates, etc., disposable cups and plates, they will be that kind of that they are all recyclable. They must be all recyclable, and there is no actually that kind of a solution on the market yet for all these things which have to be recyclable at Tokyo Olympics. But that's a huge pressure. We have products here. We just have to get our message through the globe, so that will be used for Olympics, etc. And how this links there is a link between Olympics and then of course this Coca-Cola, McDonald's, etc. They are huge brands which are supporting Olympics, big sponsors there, and if they claim in Tokyo that now everything is recyclable, it must be recyclable also in the shops and restaurants globally, and that is a big potential for us. This is what I had in my mind.
Okay.
Thank you very much.
Excellent. Thank you very much, Tapani. I just wanted to ask, what's your revenue now, and what's your prediction in 2 to 3 years, if everything goes well?
Our turnover all in all is in this in cooperation companies around 100 million at the moment, but it's really so that there is a lot of traditional products which are included to that, and this is.
Give us your best guess. Ambitious guess.
Money-wise, I'm not giving it, but hopefully we are saving environmental that way that this solution is really sustainable, and it's really good for the nature and people. So I think that its potential is so huge, but how we as a small company how we can really put our products on the market, and that's I don't have an answer yet to that. So,
okay, thank you. Tapani's presentation actually got me thinking that how many disposable cups and plates the city of Oulu is consuming every year? Maybe we have those products and your innovation inside the disposable cups next year in the Industry Summit.
Yeah,
you have a reference.
Yeah.
Okay,
so.
Thank you very much.